Hello students, welcome back. Now let's go to example problems in section 1. We went through the first problem here, but that was trivial because it was already in vertex form. Let's go to the other problems, and you can do them in two different ways. One is completing the square from the general form to the vertex form. The other way is to use the formula h is minus b over 2a, k is negative of b squared minus 4ac over 4a. First problem, we're going to complete the square. Second problem, we're going to use the formula method. Fair enough? Okay, here we go. Y equals to x squared plus 6x minus 1. Okay, here, let's complete the square, and please recall the complete square formula. A plus b squared is a squared plus 2ab plus b squared. Does everybody remember this? We need 2 here. It's part of the formula. So we need 2 here. So let's rewrite it as 2 times 3x like this. Now, does it help? Yes, it does. Because these two correspond to these two. Now, I need this b squared. So I have to put this b squared here, plus 3 squared. Now, I just artificially added something, so I have to subtract it back. Otherwise, I'm going to end up changing the quantity itself. So overall, this is adding 0. So added 9, and then subtracted 9. So first 2 highlighted in red corresponds to first 2 of this complete square formula. And then 3 squared I just artificially added corresponds to b squared, which I just artificially added. And because I artificially added something, I have to subtract the same thing back. And so much for step 1, the preparation. Next, let's go to the complete square, because this part is complete square. X plus 3 on it squared. And then we have minus 9, minus 1, so minus 10. Looks like that's what I'm getting. Did I do this right? Color coding will help. Now, what if I use the formula method? Yeah, okay, I have plenty of time, so let's use formula method for the same problem. Okay, here, and then let me see, minus of, okay. And what is b here? 6. What is a? Let me expand the font a little bit. There are too many fractions. So that's negative 3. Is everybody happy with that? Okay. Okay. And then copy and paste this thing, all right. And then a is 1. And then b is 6. So b squared is going to be 36. And then a is 1. And c is negative 1. Make sense? Oops, what did I do? Sorry about that. Okay, some wrong key. Sorry about that. I got it back. Now, this is negative of, let me see, minus minus plus negative 36 plus 4 is 40. 40 over 4, oh yes, this is negative 10. And yes, negative 10. From here, negative 3. So yes, either way, we can find h comma k. So either way, we have h comma k is equal to negative 3, negative 10. And is this maximum or minimum? It's a minimum because the leading coefficient here is positive. You can check by plotting it, and that's left to the students. Which one do you like best? Which one do you like better? Completing the square or the formula method? Me personally, I prefer to complete the square, the first method. How about the next problem here? Kind of same problem. So here we go, completing the square. Factor negative 3 out. So we have up to here. And then artificially add plus 4 minus 4. First three terms are complete squares, so minus 4, I have to bring it out. So that becomes plus 12. And then these three, they form the complete square, x plus 2 total quantity squared. And then in the end, 12 minus 2 is 10. Yes, that's how you do the complete square method. Now, what if you're going to do with the formula method? Okay, minus b, so that's negative 12. Let me expand the font. And then a is negative 3. So there are three negatives, so overall negative, and then 12 over 6. So I'm getting h equals to negative 2. Yes, it fits. Good. How about k? Alright, b is negative 12 squared, 144. And then a is negative 3. So there, negative 3. And c is negative 2. And how do you calculate it? Let's see. This negative and this negative cancel each other out. 4 times 3, that's 12. And negative, another negative. So we need just one negative. 3 times 2 is 6. 6 times 4, that's 24. So 144 minus 24, we're getting 120, and then divided by 12, that's 10, if my mental math is correct. Oh yeah, correct. Good. So either I use complete square method or the formula method, I'm going to get the same thing. Either way, h comma k is negative 2 comma 10, and that's the maximum because we have negative leading coefficient, concave down. How about these problems? Domain the range. Domain is always negative infinity to positive infinity. The range, basically we are looking for either this or that. Everything revolves around how to find the vertex form. This one is already in the vertex form, no problem there. And this one, okay, you can complete the square. If you complete the square, it's going to be like this. Y equals negative 2 x squared, and then minus 2x it'll become like this, right? -2 times -2 is +4. And then you can put something here and make it a complete square. How do you do that? I'll stop here. How about the next problem here? Y equals to -3, factor it out, x squared. Oh, this is just 2x, and factoring out -3. So I have 2/3. You get this. Does it make sense? -3, and then this -3 cancel out, and I'm going to get +2. So that's correct. And then I have to add something here, add and subtract something here to make this one into a complete square. Good luck. The second one is going to be tougher because of all these fractions. Now, if you use the formula method, b is 2, a is -3, so this whole thing is, let's see, 1/3? Okay. Now, how about k? A is -3, and b is 2, so this b squared is 4, and 4ac, -3 times -2, and yeah, you can work it out with some symbolic computation, but at this moment I'd much rather punch into the calculator to figure out. Let's see what we have actually. This negative and that negative cancel each other out. We have 12, and then this is 4, and then we don't need too many negatives, just one is fine. 2 times 3, and then that's 24. So 4 minus 24, I'm going to get -20 over 12. So -4, -5/3. Yeah, dividing by 4 from each, -5/3. Well, I don't trust my mental math completely, so you can check it with your calculator. Oh yeah, amazingly, it was correct. Okay. Oh, by the way, this is complete square method. Inserting 1/3 squared, so 1/9 minus 1/9, and that's how you can do complete square. Okay, that's it. We'll say section 1 is done, and let's meet again in separate video for section 2.